Hi, physical science students. We are diving into our next lesson today, which is over metrics and measurement. This is a lesson in Unit 1, which is our introduction to physical science. And in our previous lesson, we've learned about lab safety rules and procedures and lab safety symbols that we might see. And then in our last lesson, we looked at lab equipment that we might see this year in physical science. And now we're going to specifically talk about how we can use those pieces of equipment to measure. So in science, we use something called the metric system. And the metric system is a system of measurement that's based off of three base units. So the meter, the liter, and the gram. So meter is used to measure length, which is a distance, and liter is used to measure capacity or volume. And then gram is the base unit that we use to measure weight or mass, the mass of a substance. So one thing we need to talk about is the second bullet point. The metric system is the standard measurement system for all sciences. Regardless of where you live in the world, if you're doing scientific work, you're supposed to be doing this work in the metric system. So I know in the United States, we use an English system or a standard system of measurement most of the time. So when a baby's born, we say the baby weighed 8 pounds, 7 ounces. That's standard system. But if you're doing science work, you would have to have weight measurements in mass, which is in the metric system what we use. So I don't know, you might be too young to remember this. You may not have even been born. But in the 90s, NASA just experienced like mishap after mishap that caused many of their programs to become under major scrutiny. A lot of their funding was taken away from them because they just kept making mistake after mistake. One of their biggest mistakes came with the Mars Climate Orbiter. It was a piece of equipment that relayed climate information from Mars back to NASA. But one team of programmers was working on the orbiter in metrics, and then an ocean away, another team of programmers was working in English units. And so you wouldn't think that would be a big deal, but what happened was when this orbiter went to Mars, it was a huge deal because of the differences in measurements. The orbiter actually burned up in the Martian atmosphere. And so this was a big mistake on NASA's part, and it caused all scientists to look into their measurement system. And so what came of that is the understanding that all scientists work in the metric system. And so we're taking the time to learn about the metric system and learn about metric measurements because that's what we're going to have to use this year in the physical science classroom. So there's 4 particular measurements that we're going to look at today, and that's mass, volume, length, and time. So in the metric system, when we measure mass, we're going to measure in the unit grams. When we measure volume, we're going to measure in liters. When we measure length, that will be in meters. And you can have different versions of this we're going to talk about in just a little bit. But these are the base units. And then time is going to be measured in seconds. And it might be helpful if you have your notes beside you where you can just follow along as we go through these measurements. All right, so by definition, we're going to start with mass. And mass is the amount of matter in an object, so how much of something there is. The base unit for mass is grams, and we can abbreviate that with a lowercase g. But now mass can also be measured. We can put prefixes on the front to make mass have different values. So we can have kilograms or milligrams, and there's others we'll talk about in just a few minutes. If I want to measure mass, there's a couple of pieces of equipment that I can use. So you can use something called a digital balance, which is what we're going to use. I know a lot of science classrooms also use something called a triple beam balance, which requires a little manual labor. But either way, a balance is used to measure mass. Volume is something else that we will measure in the science classroom, and volume by definition is the amount of space that an object occupies. Now, the base unit for volume is the liter, but remember we can have different values of the liter. And so we can have deciliters or milliliters or hectoliters. There's all kinds of different variations. A graduated cylinder is what we're going to use to measure liquid volume. However, you can also find the volume of a rectangular solid by using a formula, and you've probably learned this in math. So if I want to find the volume of a rectangular solid, I can do length times width times height. So we're going to use that formula a good bit this year. Volume can also we can find the volume of an irregularly shaped object. So something that's not a liquid and it's not a rectangular solid, we can't do length times width times height. So anything that's irregularly shaped, we can use a process called water displacement. And basically what you do is you start with a measured amount of a liquid. So if you look at the picture, we're starting with 150 milliliters of this liquid or water. And then you take the object and you drop it in a graduated cylinder, and then you take the new measurement. And then you subtract the original or initial measurement from the new measurement, and that will give you the volume of the object. So water displacement is something that we might use if we have something that's not rectangular or that's not a liquid. Length, I know we'll use a good bit this year when we're in our physics unit. You have to get length for a lot of those formulas that we're going to be using. So length is just the distance between 2 points. The base unit for length is the meter, and we can abbreviate that with a lowercase m. And then we have different variations of the meter, and they have different values. So you can have centimeters, millimeters, kilometers. We use a metric ruler to measure length. And I know in my classroom, I use the rulers that have the standard system on one side, so inches, feet, and then on the other side it has metric measurements. You just need to make sure this year, anytime we measure, that you're using centimeters, millimeters, or meters. Time is another measurement that we're going to take often when we get to the physics part of the course. Time is just the interval between two events, and the base unit for time is seconds. It can be abbreviated with just a lowercase s, or sometimes you'll see it written SEC. Either way, it means seconds. You also can have time measurements in minutes or hours. Anytime we want to measure time, we're going to use a stopwatch. For us, that's most accurate. All right, so let's say we want to convert between units. So let's say you're given a gram and you want to know how many milligrams are in a gram, or you are given kilometers and you want to know how many meters are in a kilometer. So you can convert between units pretty easily. But before we talk about how to actually convert, there's a couple things that I want us to fill out on our notes. So if you'll look in the middle of the chart here, we have our base units. Again, 3 base units we're focused on: meter, liter, and gram. And then you can have prefixes that you put in front of those base units to give value. So first, let's go over the abbreviations for the prefixes. So kilo is going to have a value of 1,000, and its abbreviation is a K. Hecto's value is 100, and we're going to use an H to represent hecto. Deca is going to have a value of 10, and we're going to use a capital D, or sometimes you'll see DAG as the abbreviation for deca. And if you'll notice here, kilo, hecto, and deca are all capitalized. I use a capital letter system to help me distinguish between a deca and a deci, because they both start with D. So I use capital D to represent deca because it's larger in value, and then a lowercase d when I'm talking about deci, which is a lower value. So for our base units here in the middle, 1, they each have a value of 1. And then if we start moving to the right of our chart, we notice that our values get smaller. So a deci is going to be abbreviated with a lowercase d. Its value is 1/10. Centi or centi has an abbreviation of a c, a lowercase c, and it is worth a 100th. And then milli is abbreviated with a lowercase m, and its value is 1/1000th. All right, so if we are wanting to convert between units, there is a mnemonic device that I want you to remember. It's going to help you out a lot. King Henry died by drinking chocolate milk. And so if you can remember that sentence, King Henry died by drinking chocolate milk, that helps you sort of know the sequence of your chart. So the K in king represents kilo. The H in Henry represents hecto. The D in died represents deca. The B in bi is going to be your base units. The D in drinking is going to represent deci. The C in chocolate is going to represent centi. And the M in milk is going to represent milli. All right, so I'm going to give you a few seconds just to pause the video and fill in your chart. These are the abbreviations that we're going to use. So what I've done here is I've just kind of merged them. So a kilo and a meter when paired together is going to be a kilometer, and the abbreviation is km. Hectometer, when they come together, the abbreviation is HM. Decameter, when they come together, the abbreviation is DM, and so on. So pause the video now, fill in your chart so that you know the abbreviations. All right, so let's work out a couple of examples. We're just going to jump right in, and I'm going to show you how to convert between units. So let's say we're given 1 meter, and we want to convert this into millimeters. So we want to know how many millimeters are equivalent to 1 meter. And this is similar to saying, I have a dozen eggs. How many eggs is that? And you know the answer is 12. So these are just conversions. All right, so you start with the unit that you're given. We were given meters, so you can see here that I'm starting at the M. And then we're going to travel to the unit that we want to convert to, which in this case is millimeters. So I'm going to hop over 1, 2, 3 places to the right. So whatever I do on my chart, I'm going to also need to do in my number. So I'm given 1.0 as my starting number, and I'm going to move the decimal there 3 places to the right. So when you move the decimal 3 places to the right and fill in zeros anywhere we have sort of the dips in our arrow, then we get a value of 1,000 millimeters. So there are 1,000 millimeters in 1 meter. All right, let's try this one. We want to convert 0.05, and this is a lowercase d, so this is going to be decigrams to grams. So we're starting here with decigrams. We want to travel to grams, so we're going to move 1 place to the left, which means I'm also going to have to move 1 place to the left with my decimal in 0.05. So when I move that decimal 1 place to the left, I get 0.005 grams. All right, last one, and then we'll be done. So we want to convert 2.3 decaliters. Notice I have the capital D there, so we're using decaliters. We want to convert this to liters. So we're starting at decaliters. We're going to jump 1 place to the right. That means we also have to move that decimal in 2.3 1 place to the right. We fill in with zeros, and our new value is 230 liters. You could also write this 230 with a decimal and then a 0 at the end. That means the same thing. All right, I hope this is helpful, and I will see you in the next video.